So we're studying organic chemistry. There is a lot to understand because it's really a new field of chemistry. And everything that you've studied so far, things like bonding, calculations, everything, it's useful as a foundation to expand your knowledge in chemistry. And we apply a lot of this concept in organic chemistry to explain things like trends in different type of molecules, but we will get into the details. So now, let's have a look at the key definitions that you need to know for organic chemistry. And the first thing is really that. What is organic chemistry? So organic chemistry is the chemistry of carbon compounds. So chemistry of carbon compounds. So now I want you to, if you don't have one yet, periodic table up, and I want you to look at the position of carbon in the periodic table and think about what can you tell about the properties of carbons just by looking at the periodic table. So you will see that carbon is atomic number 6, and it has a mass number of 12 to round it. Okay. What is important with carbon is that it's a non-metal, but it's a non-metal that forms specific types of bond, covalent. And the key thing that makes it so useful is that it forms bond with itself. So it forms a strong covalent bond with itself. Remember, it has 4 electrons in the outer shell. This means that it could easily bond with another carbon, and so on. So imagine here you could have 4 different carbons attached, and each carbon is attached to other carbons, and so on. Okay, so the key point, don't worry too much about the diagram, but is that it can form a stronger covalent bond with itself. And the other important thing is that these stronger covalent bonds, yeah, can be of different type, but for now, stick with this one, is a sharing of electrons, okay, just to revise. So this type of bonds, and let me clear up a little bit the screen to make it more clear. There are 3 different types of covalent bonds that carbon can form. And the one that we've just seen is a single bond, when there is 1 pair of electron between each carbon. We can schematically write it with a line. So this is a single bond. But carbon, because we know that carbon has 4 electrons in the outer shell, it can share actually more than 1 pair of electrons. So what if I tell you that there are now this many electrons between them? It's a double bond. And there are going to be 2 electrons spare for each carbon. Remember, dot and cross diagrams. But it doesn't finish here. Carbon can even share 3 pairs of electrons with itself, leaving behind just 1 that will bond with something else. This is a triple bond, and this is as far as it can go. So carbon forms covalent bond with itself, can form single, double, and triple bond. Okay? And organic compounds, now they're a bit more complex than that, but the backbone of this compound is the carbon. Okay? So carbon, this type of molecules, they are classified in what is called homologous series. 2 definitions here I want you to understand is that we can expand a bit this, the understanding of organic molecules. Homologous series and functional group. So homologous series, it's a series of compounds with the same functional group, but a different number of carbon atoms. which means that a functional group is a specific atom. Let's write it down. Is a specific atom or a specific group of atom or group of atom that determines or conferred certain properties. Let's say that determines chemical and physical properties. To the molecule. And remember, this molecule, it's made of carbon, but it has these extra atoms that will affect the properties of this carbon molecule. And homologous series are organic compounds with the same functional group. Yeah, but different number of carbon atoms. Bit longer definition, so you may pause and finish writing down before I move on. Okay, so take a moment for that. Let's look at some example of these organic compounds, homologous series, and functional group to understand better. So the simplest type of organic molecule would be when carbon is bonded to itself. But then you may ask, what else is bonded around it? Hydrogen. So carbon, if it's not bonded to itself, in the simplest form, is bonded to hydrogen. Okay? So always carbon and then bonded to hydrogen. This is the simplest one. It doesn't really have any functional group. Let's take a similar one, a molecule that still has 2 carbons, which is bonded with these many hydrogens, but now it has this, OH. This is a specific atom, like it's an atom or a group of atoms, oxygen and hydrogen, that will affect the properties of this C molecule. So this would be a functional group. A molecule that has the same functional group but different number of carbon could be this one. Notice that I've added another carbon. Remember, it's full of hydrogens. Yeah, those two are from the same homologous series. Remember that each member of an homologous series differ. Yeah, so you just need to add one CH2 because carbon, and that's the very important thing that you can never forget, carbon has a maximum of 4 bonds. You cannot ever forget that. Okay, it's a maximum of 4 bonds. So as a little practice now, I want you to write a member of the same homologous series, HS, homologous series, as this one. So write in the same formula, like this is the same as I wrote it, another member of this homologous series, yeah, as this C2H5. Take a moment, and when you're ready, play again. So if we have a C2H6, notice there are 6 hydrogens, then remember, homologous series, a series of compounds that have the same functional group. They only differ by carbon, number of carbon atoms, and therefore hydrogens. And if you want to go to the next member, you just add a CH2. So if we have these at the top, change color, the next member would be with the 3 carbons. And remember that with each carbon, we add hydrogens too. So there we go. We have an extra CH2 that makes the next member of the homologous series. So these are the first key definitions of organic chemistry. In the next part, we will look at the type of formula because we've already practiced a little bit, but we need to get very confident in writing down the organic molecules in different ways.